Question 1. So part A, we've got to make A the subject of the formula. So we've got to go from it being M equals to being A equals. So first of all, focus on the second term, the term furthest away from the term including A. So we want to undo this minusing of BD by adding BD to both sides. So M plus BD equals AC. Now we want to make A the subject, so we just need to undo this timesing by C. So divide both sides by C. So A equals M plus BD all over C. Now for part B, we're just going to make X the subject here. So just as if this was saying equals 39, just sort of the algebra would do will be just as if it was 5x minus 4 equals 39. So start off by adding 4 to both sides. So 5x is less than 43. Divide both sides by 5. So x is less than 43 over 5. Or x is less than 8.6 if you want. Now part C, it says factorise fully. So the fully bit, circle that and remind yourself that's going to mean you're going to be taking more than one component outside the bracket. So we work our way along. So what's the highest common factor of 18 and 12? Well, that's 6. Highest common factor of e squared and e cubed, well that's e squared, and highest common factor of f cubed and f, well that's f. So all three components have to come outside your bracket. So the first term inside the bracket, 6e squared f times what gives us 18e squared f cubed. Well, we need a 3, so it's 6 3s are 18. We're already there on the e squared, and f times f squared is going to give us our f cubed. Get the sign right, so it's going to be a minus. And we need 12 here, so 6 times 2 gives us 12. We've got e squared already, so e squared times e is going to give us our e cubed, and we've already got the f in place. Question 2. So work out the difference between the largest share and the smallest share when 3450 yen is divided in the ratio 2 to 6 to 7. 2 to 6 to 7. So how many shares have we got in total? Well, 2 add 6 add 7 is 15 shares. So how much is each share worth? So we do the 3450 yen divided by 15 to see that each share is worth 230 yen. Now we've got to work out the difference between the largest share and the smallest share. Well, the largest share is 7 shares and the smallest share is 2 shares. So the difference between the largest share and the smallest share is 7 take away 2 is 5 shares. Well, each share is worth 230 yen, so 5 lots of 230 gives us 1150 yen. Question 3. Well, Gopal was given an increase of 8%, so let's work out their new salary. So if you're getting an increase of 8%, the multiplier we're going to use is 1.08. So 20,000 times 1.08 means Gopal's new salary is 21,600. Now Jamuna is going to be getting the same new salary, so they're also going to be getting 21,600. So how much increase are they going to be getting? Well, it's gone up from 19,200, so their increase is 21,600 minus 19,200, which is 2,400. Now we've got to work out the percentage increase that Jamuna was given. So the actual increase itself is 2,400, but what is the percentage increase? Now to work out a percentage increase, you divide the increase by the original amount and times this by 100. So the increase is 2,400. Divide it by Jamuna's original salary of 19,200. Times this by 100 gives us 12.5%. Question 4. So 3 4/7 is the same thing as 25 over 7 when we make it into an improper fraction. 3 7s are 21 and add the 4 to get the 25. And 1 5/8 is 13 over 8. 1 times 8 is 8. Add the 5 to get the 13. Now, in order to subtract fractions, you need a common denominator. You need the same number on the bottom. So 7 and 8 both go into 56, so let's make our common denominator 56. So we need to find the equivalent fraction of 25 over 7. That is how many over 56? Well, 7 times 8 gives us the 56. So to leave the fraction unchanged, we've also got to multiply the 25 by 8. 25 times 8 is 200. So 200 over 56 is the same as 25 over 7. Now moving on to the 13 over 8, turning that into something over 56, we're going to times top and bottom by 7, because 8 sevens are 56. So 13 times 7 is 91. Now that we've got the common denominator, we can subtract the numerators. 200 take away 91 is 109. So that's 109 over 56. Turning this into a mixed number, one whole uses up 56 bits out of 56, leaving 53 left over. So that's 1 and 53 56, as we had to show. Question 5. Well, we've got to work out the size of angle PQT, which I've labelled X on the diagram. So first things first, this angle here, this angle OQP, is also going to be 18 degrees because this triangle QOP is an isosceles triangle, because both these lengths here are radiuses. So the base angles are equal of an isosceles triangle, so that's the reason I've just popped down there in purple. Now once we've established that's 18, then we're nearly there. Now the angle OQT, that little black angle there, that's 90 degrees because this is a tangent. QT is a tangent to the circle, and the angle between a radius and a tangent is 90 degrees. So angle OQT is 90 degrees because the tangent is perpendicular to the radius. Now, given that the whole angle OQT is 90 and that part of that angle OQP is 18, it means the remainder of that angle PQT must be 90, take away 18, which is 72 degrees. Question 6, part A. Work out the curved surface area of cylinder A. So just imagine unwrapping this cylinder. The curved surface area A is going to be a rectangle which has got a depth of 1.6, and the width of the rectangle is going to be the circumference of the circle, the circumference of the cylinder before we unwrapped it. Now circumference is pi times the diameter, and 0.56 is the radius, so the diameter is double 0.56, so the circumference is going to be pi times 2 lots of the 0.56, so that gives us the 1 length, and then we multiply this by the 1.6, giving us 5.629 ... which to 3 significant figures is 5.63. Now for part B, we're told that cylinder B is mathematically similar to cylinder A. So they're proportionally similar. So what have we multiplied 1.6 by to get the equivalent length on cylinder B? So 1.6 times what gives us 0.6? So I've done 0.6 divided by 1.6, and I can see that it is 3/8. So all the lengths in shape B are going to be 3/8 of the equivalent length in shape A. So the radius of cylinder B is going to be 0.56, the radius of cylinder A, multiplied by 3/8, giving me 0.21 meters. Question 7, part A. So we're going to work out the mean score of the students in class B. Okay. Now, let's start off by working out the total marks for Class A and Class B together. So the number of students is 28 and 32, and the mean score for all the students in both classes is 72.6. So multiply the number of pupils, which is 60, by 72.6, gives us the total marks scored for the pupils in both classes A and Class B together of 4356. Now this is easier to see the other way around, isn't it? The total marks they got is 4356. Divide that by the 60 pupils, gives us the mean mark for both classes of 72.6. Now moving on to Class A, where we've got 28 pupils. Their mean score was 75, so their total marks must be 2,100. Or again, looking at it the other way, total marks of Class A pupils 2,100, divide by the 28 pupils, gives us the mean of 75. So 4356 is the total marks of Class A and B together, 2100 is the marks of Class A on its own, so the Class B marks must be the difference. So 4356 take away 2100 gives us the total number of marks achieved by the Class B pupils of 2256. So they've achieved 2256 marks, divide that by the 32 students in Class B, gives them a mean average of 70.5. Now for Part B, let's just start off by working out the highest mark in Class A. So we're told that the lowest score is 39, yet the range is 57. Well, remember the range is the highest, take away the lowest. So our highest mark for Class A must be 39, add the 57, which is 96. And similarly for Class B, their highest mark has got to be 33, add 60, which is 93. Now to work out the range across both classes, we're going to need the highest mark in either Class A or Class B, which is the 96 from a Class A pupil, take away the lowest mark from either Class A or Class B, which is the 33 achieved by a Class B pupil. 96 take away 33 gives us 63. Question 8. So we're working out a side when the question which is involving angles and lengths is the right angled triangle, so we're going to be using SOHCAHTOA. So remember, silly old Hitler caused awful havoc to our armies. So these are the three ratios we need to learn. And with this particular question, we know the adjacent side and we've got to work out the hypotenuse. So adjacent and hypotenuse involved. So on this occasion, we're going to be using cosine. Now cosine the angle, so cos 52 equals our adjacent side of 12.6 divided by our hypotenuse of x. You must get it the right way round. It is the adjacent divided by the hypotenuse, 12.6 over x. Now to make x the subject of this, there's sort of a double two bits of algebra. We start off by multiplying both sides by x, and then we divide both sides by cos 52. So x equals 12.6 divided by cos 52, not the other way around. Popping this into our calculator, we get 20.465 ... which is 20.5 to three significant figures. Question 9. Now we need to line up either the x's or the y's. So you need to choose to either multiply equation 1 by 7 to line up the x's, or as I've done, multiply equation 1 by 5 to line up the y's. So taking equation 1 and multiplying each of the terms by 5, I get 5x plus 5y equals 75. So now when I compare that to my equation 2 of 7x minus 5y equaling 3, I've got the same numerical value of y's, 5y. Now in order to eliminate the y's, because the signs of the y's are different, I'm going to have to choose to add these two equations together. So 5x plus 7x is 12x. 5y added to minus 5y is nothing, and that's the whole point. We wanted the y's to eliminate. And 75 add 3 is 78. So 12x equals 78. So divide both sides by 12. We get x being 78 over 12, which is 6.5. Now to work out y, I start again. So I take either of the equations, might as well take the top one as it's easier to work with. X plus y equals 15, but I've just worked out that x is 6.5. So 6.5 add y is 15. Take away 6.5 from both sides, we get y equaling 15. Take away 6.5, so y is 8.5. Question 10, part A. Now we need to make the big number the same throughout, and that's going to be the smaller of the numbers that we're starting with. So we need to appreciate that 8 is the same thing as 2 to the power of 3, because 2 times 2 times 2 is 8. Now that we've got the same big number, we can just follow the index laws. So when we're dividing, we subtract the powers. 3 take away 7 equals minus 4. So n is minus 4. Now with part B, you need to remember that when you've got a power inside the bracket and a power outside the bracket, we multiply these together. So 13 to the power of minus 6 all to the power of 4 is 13 to the power of minus 24. Now when we're multiplying, we add the powers. Minus 24 add 5 means that k is minus 19. Question 11. Now note how I'm utilising one of the formulas that were given at the front of the paper. So we've got to work out the density of the sphere. Density equals mass divided by volume. So I'm going to need to work out the volume of the sphere using the given formula. So the volume of the sphere is 4/3 pi r cubed. We're told that the radius is 1.5. So that's 4/3 times pi times 1.5 cubed, which is 9/2 pi. Now density equals mass divided by volume. The mass is 109.6 grams, and I've just worked out the volume to be 9/2 pi centimeters cubed. Now just take a second just to check there is not going to be any complication with the units. We're being asked to give our final answer as grams divided by centimeters cubed. The mass is already in grams. The volume is already in centimeters cubed, so there's no complications with this question. So we simply have to do 109.6 divided by 9/2 pi, giving me a density of 7.7526 ... which to three significant figures is 7.75 grams per centimetre cubed. Question 12. So the first thing I've done here is note that these two lines are parallel here. AD is parallel to BC, so we can work out this angle here, ADC, as being 180 minus 42 degrees, which is 138, because it's the C angle rule. I don't know if you've come across that one. So the co-interior angles, the angles inside the parallel lines, add up to 180. If you haven't come across that rule before, that's fine. You could just extend the line CD, and then you would be saying this angle, the other side here, this angle, the other side of AD up to the extended line, is also going to be 42 degrees, because our corresponding angles are equal, and then this angle will be 138 as you took that away from the 42 degrees. So we've got this angle here being 138. Now what we know is that the angles inside a hexagon add up to 720 degrees. Now if you haven't learned that, which is fine, not many people have, just break your hexagon down into triangles, and you can see if we're going from point E that we've got 1, 2, 3, 4 triangles. The angles inside a triangle add up to 180 degrees, so the total of the interior angles of this hexagon must be 4 lots of 180, which is 720. So working our way around the interior angles, we're saying 96 plus 50 plus this interior reflex angle Y plus 138 plus 42 plus 144 equals 720. So we've constructed an equation which we can simplify and solve. So gathering up our normal numbers on the left, we get 470 plus y equals 720. Taking away 470 from both sides, we get y being 250 degrees. Now we're being asked to work out the size of the obtuse angle DEF. So that's the angle greater than 90 but less than 180 degrees here that I've marked X. So given that Y is 250 degrees, X must be 360, take away the 250, which is 110 degrees, because angles about a point add up to 360 degrees. Question 13. So the key bit to take on board here is that Felix does not replace the cards. So as we take a second card, we're going to be choosing from 9 cards, not 10. So as we take our second card, if a red has already been chosen, the probability of a red with our second pick is going to be 4, because obviously one of the red cards is gone, 4 out of 9. The chances of a blue is still 4, but 4 out of 9, and of a green is 1 out of 9. Now, what about if a blue's been chosen first of all? The chances of getting a red is going to be 5 out of 9. One of the blues will have gone, so the chances of getting a blue will be 3 out of 9, and the chances of getting a green will be 1 out of 9. Now, what about if we've selected a green to start with? And the chances of getting a red are going to be 5 out of 9, blue 4 out of 9, and 0 probability of getting a green because the green one's already gone. Now for part B, we've got to work out the probability that Felix takes at least 1 blue card and no green card. So these are the 3 branches that we're interested in, where we got a red and then a blue, or a blue then a red, or a blue then another blue. Those are the only 3 ways that we can get at least 1 blue card and no green cards. So how do we end up here? Well, it's the 5/10 times the 4/9, because we needed a red and a blue. Remember, when it's an and in your head, you multiply. So 5/10 times the 4/9, giving us 20 over 90. What about a blue and then a red? That's going to be 4/10 times 5/9. And the third journey of interest is this blue and then another blue, 4/10 times 3/9, giving us 12 over 90. Now we don't mind whether it's this option or this option or this option. We add these 3 together. So you add together when it's an or, 20 over 90, add 20 over 90, add 12 over 90, gives us 52 over 90. You could simplify this, but you don't need to get full marks. Question 14. Now, to complete this table, I mean, it's a good idea if you know how to do it, that you can use the table option on your calculator. If you're going to do that, do make sure that you go up in steps of 0.5, because some of our steps were just going up by a half. So if you do know how to use your calculator utilizing the table function, this is a good opportunity to do so. If you haven't got that option, then that's fine. You're just going to have to substitute each of these in. So just being careful to protect the minors. As you pop this into your calculator, make sure you do -2 in a bracket cubed, -2 times -2 in a bracket squared, -3 times -2 in a bracket, plus 4, and that will give you -6, and so on. So do protect the minors as you're going, because you've got to be careful, because if you just go and put -2 squared into your calculator, it would give you -4, not +4. You need to put the -2 in a bracket. So these are the values you get, and then when we plot this, we get this cubic graph here in blue. Now for part C, by drawing a suitable straight line on the grid, find estimates for the solution x cubed minus 2x squared minus x plus 1 equals 0. Now we've got to bring this into line with the graph that we've got. We've got x cubed minus 2x squared minus 3x plus 4. So to convert this into minus 3x plus 4, we're going to have to choose to subtract 2x and add 3 to both sides. That then gives us x cubed minus 2x squared minus 3x plus 4 equaling minus 2x plus 3. So we've already got the cubic graph of y equaling x cubed minus 2x squared minus 3x plus 4. So we just have to add the second graph of y equaling minus 2x plus 3 and then see where these two curves intersect, these two graphs intersect to get our solutions. When I say curves, minus 2x plus 3 is of course a straight line. So this second graph is going to be a straight line. Now to plot y was minus 2x plus 3, you just need 2 or 3 points just to, well you need 2, but I would suggest you work out 3 points just to be on the safe side. So I've opted for the values of x equaling 0, x equaling 3 and x equaling minus 1, just to sort of give me 3 that are quite nicely spread out. So when x is 0, substituting in I get minus 2 lots of 0, which is 0, adding 3, y equals 3. When x equals 3, substituting in, that's going to give me minus 6 plus 3, which is minus 3. And then when x is minus 1, minus 2 times minus 1 is plus 2. Add the 3, you get the 5. So I've plotted these 3 points here in purple and then drawn in a straight line with my ruler. Now my 3 solutions, and I'm getting 3 solutions because my line crosses the cubic graph on 3 occasions. My 3 solutions are at x being minus 0.8 here, x being 0.6 here, and x being 2.2 here. Now the mark scheme does allow a little bit of flexibility because it's quite hard to take these readings off the graph. So as long as your answers were close to this, you will have got full marks. Question 15. So to work out the lower bound when I'm subtracting, I need to have the smallest possible value for e, so the lower bound for e, and I'd need to take away the biggest possible number, so the upper bound for f. Now the lower bound for e, what's the smallest number that would round up to 8.31? Well, that's 8.305. And what's the upper bound for f? Well, that's 0.655. So pop that into your calculator and you get 7.65. Question 16, part A. So r is proportional to t squared. So my starting point is the provisional formula r equals kt squared. Now I now need to take a reading for r and t to allow me to work out the constant k. Now I've taken this reading here, so I know when t is 2, r is 10. So substituting t being 2 and r being 10 into my provisional formula, I get 10 equaling k times 2 squared. So 10 equals 4k. Dividing both sides by 4, I get k equaling 2.5. So my final formula is r equaling 2.5 lots of t squared. Now for part B, I'm given also that r equals 8 over 5x, and I have to show that t is inversely proportional to root x. So start off by substituting in what we know r is equal to. So replace the r on the left hand side with your 2.5 t squared. Your answer from part A. So 2.5 t squared equals 8 over 5, 1 over x. That's the same thing as 8 over 5x. Now dividing both sides by 2.5, I get t squared equaling 16 over 25 multiplied by 1 over x. And then square rooting both sides, I get t equaling the square root of 16 over 25, which is 4 over 5. Square rooting 1, I get 1. Square rooting x, I get root x. So t equals 4/5, which is 0.8, divided by root x. Question 17, part A. So to differentiate, remember you multiply by the power and reduce the power by 1. So x cubed becomes 3x squared. Moving on to our second term, multiplied by the 2. So minus 2 times 2 is minus 4. Reduce the power by 1, so that's minus 4x. Then differentiating minus 15x, you get your minus 15. Now for part B, work out the range of values of x for which c has a negative gradient. So this has a negative gradient where the differential is less than 0. So set 3x squared minus 4x minus 15 to being less than 0. Now this factorizes, so two magic numbers that multiply to be the 3 times the minus 15, which is minus 45, yet add to be the minus 4, so that's 5 and minus 9. So breaking down this middle term, I get 3x squared minus 9x plus 5x minus 15 being less than 0. Fully factorize the first two terms, I get 3x, x minus 3. Fully factorize terms 3 and 4, I get 5 lots of x minus 3. So my final answer is the pair of brackets comprising the 3x plus 5 in the first bracket and the repeated bracket in the second bracket. So what values of x would be the roots to this equaling 0? Well, that's going to be minus 5 over 3 to make this first bracket equal to 0, and plus 3 for the second. Now I'd like to do a little sketch just to help me gather my thoughts on which values I require. So it's a positive parabola. This is a smiley face graph, the 3x squared, so it's a positive parabola. Roots at minus 5 over 3 and 3. Now I want all the solutions which are less than 0, so it's this stretch of points below the x-axis, so where x is less than 3 but greater than minus 5 over 3. Question 18. So I've just done a quick sketch to help me gather my thoughts on which is going to be the biggest angle, and when you think about it, it's going to be the angle that's opposite the biggest, the longest side, so it's going to be this angle here between the 8 and the 10. So when you're trying to work out an angle and you've got all three sides, you use the rearranged cosine rule. So the cosine rule says a squared equals b squared plus c squared minus 2bc cos a, where lowercase a, b and c are the three sides and uppercase A is your angle. So rearranging this, so subtract a squared from both sides, add 2bc cos A to both sides, then divide through by 2bc, you get cos A equaling b squared plus c squared minus a squared all over 2bc. So the only thing we have to be careful about with our diagram is just, or our lettering rather, because capital A is going to be our angle, then the opposite side, the 14, has to be our lowercase a. Doesn't matter which way around our b and c go. So cos A is going to equal 10 squared plus 8 squared minus 14 squared all over 2 times 10 times 8, giving us cos A equaling minus 0.2. Inverse cos both sides, you get A being 101.536 dot dot dot. So to one decimal place, that's 101.5 degrees. Question 19. Now I think almost the hardest bit here is really getting to grips with what they're asking. Work out the size of the angle between the line BE and the plane ABCD. Now you've really just got to picture the two-dimensional triangle EDB, and that's the angle that we've got to work out, that angle at B. So just hook out the appropriate 2D triangle. So the triangle EDB, and what they're asking for us is the angle between EB and the plane. Now the line directly below EB, as you cut down through the shape, takes you down to the base of BD. So this is the triangle we're working with. Now as things stand at the moment, we know that ED is 10, because that's the same as FA, but we don't know the length EB or the length DB as things stand. So we need to go and hook out another triangle to allow us to work out one of these two sides. Now there isn't an easy way to work out EB, but DB we can work out if we go and consider the triangle, the right angled triangle DAB. Now the triangle DAB, the angle at the angle DAB is the right angle. The length from D to A is 8, because that's the same as B to C, and the length from A to B we can see is 24. So using Pythagoras, we can say dB squared equals 8 squared plus 24 squared. Square root this, we get the length of dB being 8 root 10. So we're taking our dB being 8 root 10 over here. Now that I know two sides, I can work out the angle that I need to work out. So ED is opposite, dB is adjacent, so it's going to be tan x equals 10 divided by our 8 root 10. Inverse tan both sides, we get x equaling inverse tan 10 over 8 root 10, which is 21.568 dot dot dot, which to one decimal place is 21.6 degrees. Question 20. We're told 6 of the babies had a birth weight less than 2.5 or greater than 4 kilograms. So how many baby squares have we got which are less than 2.5 or greater than 4? So less than 2.5, we've got a base of 5, a height of 4, so 20 baby squares there. And then greater than 4, we've got these squares here, so 10 baby squares here. So 30 baby squares in total, the 20 at the 10, represent 6 babies. Now, how many baby squares have we got between 2.5 and 4? Well, so I've just worked out the area of these 4 rectangles here. So this is 5 times 4 is 20. This is, what is this one? This is 4 times 20, which is 80. This is 2 times 25, which is 50. And this is 4 times 15, which is 60. So add up these purple baby squares and we get 210 baby squares. Now 30 baby squares was 6 babies. I've now got 7 times as many baby squares. 210 divided by 30 is 7. So I'm going to have 7 times as many babies. 6 times 7 equals 42 babies. Question 21a. So simplify both of these surds. So root 45 is the same thing as root 9 root 5, which is 3 root 5. Root 20 is the same thing as root 4 root 5, which is 2 root 5. 3 lots of root 5 and 2 lots of root 5 is 5 lots of root 5 as required. Now for part B, we need to rationalize this surd. So choose to multiply top and bottom by the denominator with a change of sign. So we're going to multiply top and bottom by root 3 plus 1, not root 3 minus 1. So when we multiply our numerator, we get 2 lots of root 3 plus 2. And then when we multiply out the pair of brackets on the bottom, because we've got this change of sign, our 2 middle terms will cancel out. So root 3 times root 3 is root 9, which is 3. Root 3 times 1 is plus root 3, minus 1 times root 3 is minus root 3, and minus 1 times the 1 is minus 1. And those 2 middle terms cancel out, plus root 3 minus root 3 is nothing, leaving us with 3 minus 1, which is 2 in the denominator. Now we can go and just divide the numerator, both terms in the numerator, by 2. So 2 lots of root 3 over 2 is root 3. And 2 over 2 is 1. So writing it in the required format, we get 1 plus root 3. Now for part C, you just have to, although it looks a bit weird, you've just got to follow your standard practice for completing the square. And your starting point when you're completing the square is to make it x plus half the coefficient of the x, being all squared. So what is half of 6 root 2? Well, that's 3 root 2. So our bracket is going to be x plus 3 root 2 all squared. Now we need to just then back out the unwanted bit, the fourth claw, when the 3 root 2 multiplies the 3 root 2. Now 3 root 2 times 3 root 2 is 3 times 3, which is 9. Root 2 times root 2 is root 4, which is 2. And the 9 2's are 18. So we've got to back out the 18, so x plus 3 root 2 all squared minus 18. That together is exactly equal to x squared plus 6 root 2 lots of x. You multiply that out, that pair of brackets, take away 18, that will equal these two terms. And then don't forget the minus 1 on the end. So gathering up the minus 18 with the minus 1, we get x plus 3 root 2 all squared minus 19. Question 22. Now I thought this was pretty difficult. So remember the two circle theories that are unique for the IGCSE. So it's these two here. So we've got AB times BE equaling CB times BD. So we're going to use a bit of that to start with. Then we're going to move on to using this one, which is CB times CA equals CE times CD. So with the shape we've got, the diagram we've been given, I've chosen to extend this line from D to O through to the other end, and I'm going to choose to call that point G, and similarly I'm going to extend that line through CE to O over to the other end of the circle, and I'm calling that point H. Now to start off with, I'm going to be focusing on using this first circle theory, and it's the bit up here marked in purple. So I'm saying that DF times FG is going to equal AF times FB. So that's just literally using this one here, this circle theory here. Now what do I know about the length from F to G? Well, that's a radius gathered together with a radius minus 2. That length there is going to be the full radius less 2. So that length from O to F is R minus 2, and obviously from O to G is R. So overall, going from F to G is 2 lots of R minus 2. So substituting in DF, I've got 2 times FG, which is my 2R minus 2, equaling my AF of 7 times my FB of 4. So multiply out the bracket, I get 4R minus 4 equaling 28. Add 4 to both sides, divide by 4, I can work out that the radius of the circle must be 8. Now that I know that, I can then move on and use the second circle theory over here. So I'm saying CB times CA equals CE times CH. CB is 5, CA is all the way is the 5 plus the 4 plus the 7, which is the 16. CE is my unknown X, and my C all the way to H is my 2 lots of radius, so my 16 plus my unknown X. So multiplying out on the right hand side, I get 16x plus x squared equaling 80. Take the 80 to the other side, so we've got a quadratic equaling 0. X squared plus 16x minus 80 equals 0, and this factorizes. What multiplies to make minus 80 but adds to be 16, that's 20 and minus 4. So my pair of brackets are x plus 20 and x minus 4. Now my first solution, x being minus 20, clearly isn't valid because x is a length, you can't have a negative length. So my second solution, x being 4, is my final answer. Question 23. Now I think this is a very unreasonable question because you've really got 3 unknowns and 2 equations, and it only works out because it equals 0. So I didn't like this question at the time, and I still don't like it. But anyway, this is how we had to go about doing it. So the sum of the first 48 terms of an arithmetic series is 4 times the sum of the first 36 terms of the same series. So let's just think through the sum of the first 48 terms. So we're using the given formula. This is given in the formula sheet. So obviously n is going to be 48, n is 48. So substituting that in, we get 48 over 2 multiplied by 2a plus 48 minus 1 times the d. Now what we know is this is 4 times this gives us a sum which is 4 times the sum of the first 36 terms. So if we go and let the sum of the first 36 terms equal x, what we're going to get with the sum of the first 48 terms is 4x. So let's set this equal to 4x. So then just multiplying through, we end up with this. Divide through by 4, and we've got an equation with three unknowns. We've got a, d and x in it. Now then, looking at the sum of the first 36 terms and substituting in, we now set this equal to x, because this sum is going to be 4 times as small as the other one. And again, this gives us, so we've got another equation equaling x, and so we can clearly set these two being equal to each other. So 6 lots of 2a plus 47d equals 18 lots of 2a plus 35d. Simplifying this, we can say that a equals minus 14.5d. Now, we've been asked to find the sum of the first 30 terms of this series, so if we just substitute in with n now being 30, we get this. And the only reason this works is because our d's cancel out. So we've got 2 lots of a, which is 2 lots of a minus 14.5d, plus 29d here. They cancel out, giving us the sum of the first 30 terms being equal to 0. So it does work out, because it's just, but you could only work out the sum of the first 30 terms. You wouldn't be able to work out the sum of any other number of terms. This only works because the sum of the first 30 is such that this bit just cancels out. So I think, given you couldn't go and work out the sum for any other number apart from 30, just makes the whole question a bit silly, really. But there we go.